Here I've typed my experimental data into an Excel file. Now notice that the Excel file is a grid. Each little square in the grid is called a cell. And I can type anything I like into one of these cells. Let's type a little title here. I'll double click on the cell and I'll say calculating the drop factor, and then I can hit enter at the end to get out of the cell. And now let's type that in. So I did that same thing to enter all of my data, and I'm making a little table here with drops in the first column and milliliters in the second column. And now here's where my drop factor, drops per milliliter, is going to go. Now I want to have Excel calculate these things. First thing I do when I want to do a calculation is click on the cell and then type an equals sign. Equals means get ready to calculate something here. So you always have to put the equal sign first. And now I want to have drops divided by milliliters. So what I'm going to do is click on the cell for drops. And notice that it inserts a cell reference in here. The cell reference is the address of the cell. Notice that the columns have letters and the rows have numbers. And this is in column A in row 3, so the cell reference is A3. Now I want to divide that. I hit the slash key, that's divided by milliliters. And I put in the cell reference for that automatically, B3 that was. And then I hit enter and it calculates the number. If I want to go back to that cell, I can double click on it and it will show me the formula again. When I want to get out of that cell again, I hit the enter key. Alright, now I want to do that same thing for all of these other rows, but I don't have to type that formula in again and again. There's an easier way to do it. I will go and click on this formula, and now what I'm going to do is I'm going to drag it down, and Excel is smart enough to know that when I drag the formula down, it will drag the cell references down to the data in the next row. So if I drag this down, to drag it down, I'm going to hover over the bottom right hand lower corner until I see a little black plus sign here. And I'm going to drag it down here, and if I do that, it calculates it from this row. If I double click on that, I can see the formula that I put in there. It's A4 over B4. Now let's do the same thing. I could have just dragged this down over all of the cells at once. You don't have to do it one at a time, and it will go ahead and fill the formula in for all those. So it's just as easy in Excel to do calculations on one piece of data as it is to do it for the whole set of data. And I really encourage you to play with this and get comfortable with it because it can save you a tremendous amount of work this semester. Now the last thing we want to do here is calculate the average drop factor, drops per milliliter. Now, Excel has got a lot of functions built in that help you do common jobs, like averaging is a common job. I want it to calculate an average here, so I type an equal sign. And to get it to calculate an average, I just have to type the word average. And now after I type in this function name, average, I'm going to have to type an open parentheses. And I'm going to have to put after that the numbers that I want to average. How do I do that? I am going to go up here and click on the first number, and holding my mouse down while I do that, I can drag over all of the numbers that I want to average. And notice I put in a range of cell references. Go from C3 to C7. The colon means go to. So that's a range. It's two different cell references with a colon between them. And then I have to close that parentheses. And now here is the formula for calculating the average for what's in cells C3 through C7. I'm going to hit enter. And it calculates the number for me. What about significant figures if you're worried about reporting this to someone? Well, you might think that the guidelines could be used here. But we can do better than the guidelines for significant figures. Significant figures guidelines I use when I have one piece of data. I'm doing one calculation. For example, if all I had was this first row, I'd look at this and I'd say, well, drops, that's a small count, so it's an exact number. And milliliters, it looks like I know that to 3 figures. So this number here I should know to 3 figures, and I'd say 19.6. And that's as good as I can do with one piece of data. But when you've got a lot of data, you can do better than that. Take a look at all the data, all the calculations that you've got here. And if I look here at the tenths place, it's really jumping around from place to place. And if I look at the ones place, that's jumping around too. So really the first uncertain figure is the ones place. So if I was going to report this average to someone, I'd say I'm uncertain in the ones place. So I would report it just like that. A 20 with a decimal point after it would show that I know this average to the nearest drop. It's uncertain in that